In this video, we're going to talk about probability rules and Venn diagrams. First, we have to talk about what's called a probability model, and that is a description of some chance process that consists of two parts. So that is a list of possible outcomes and then the probability for each outcome. So what we call the list of all possible outcomes, this part of the probability model, that's called a sample space. So that's where you list out all the things that could possibly happen. And then another word we have to talk about is called an event. An event is any collection of outcomes from some chance process. And then the way that we express probability is we use a P and then in parentheses whatever it is that we are looking for the probability of. If it's an event that is called A, then we would say P parenthesis A end parenthesis. And that's going to be the number of outcomes in event A all over the total number of outcomes in a sample space. Let's look at a quick example here about spinning a spinner. A spinner has three equal sections. We've got red, blue, and yellow. Equal sections, so equal probability of landing on each of those colors. Suppose you spin the spinner 2 times. Let us give a probability model for this chance process. So when you list out a sample space or a probability model, you want to list all the things that can happen. Now, of course, I color-coded this because, well, you know me. So 2 spins, that means I could get a red red, a red blue, a red yellow, a blue blue, a blue red, a blue yellow, a yellow yellow, a yellow red, or a yellow blue. Now, all of these are equal, and that means that all of these have an equal chance of happening. So each of these, each individual one, has a 1/9 chance of happening, because there are 9 total, and whatever combo you get one time is 1 out of 9. Next, let us define A as spinning blue at least once. So let's find P of A after that. So there are 5 outcomes with at least 1 blue in them, and if there are 9 total, we would say that the probability of A, which is spinning blue at least once, so P of A is 5 over 9, because 5 out of those 9 times you're going to get a blue at least once, and that's approximately 55.6-ish%. All right, some basic probability rules coming at you. First, if all outcomes in the sample space are equally likely, then the probability that event A occurs is that definition of P of A that we looked at a few slides back. Second, the probability of any event is between a number 0 and 1, or 0 and 1%. There is no way for a negative percentage to happen or more than 100%. So stick to 0 to 1. Third, all possible outcomes together must have probabilities that add up to 1. Duh, 100% should all add up to 100% of all the possible things that could happen. Last, the probability that an event does not occur is 1 minus, or 100% minus the probability, if it's a percentage, that the event does occur. And in mathematics, we call that the complement rule. So the complement rule is this fun thing. So it's P of A, right? So the thing that we are looking to happen, maybe it's all blue, for example, to the power of C. So that's how we denote that it is a complement of A. So all the things that can happen that are not A is the complement. So that's 1 minus probability that A occurred, where A of C is the complement of event A. So, for example, what is the probability of rolling 2 dice and not getting a sum of 5? One thing you could do is you could map out all 36 possible rolls of 2 dice. You probably knew that was 36. 6 times 6, 36. And you could count up all the 1s and the 2s and the 3s and the 4s and the 6s and find out what your probability is. Or you could count up all the 5s and subtract it from 1, or 100%. So probability that the sum is not 5 is going to be 1 minus the probability that the sum is 5. And there's 1, 2, 3, 4. 4 out of 36. So that means 32 out of those 36, or about 89%, is going to be a sum of not 5. So that's how we use the complement. Another rule that's pretty useful is something that has to do with things being mutually exclusive. So if 2 events A and B are mutually exclusive, that means that they have no outcomes in common. They cannot exist at the same time. That is, if P and A is equal to 0. If A and B don't happen together, the likelihood that they will is 0%. So the addition rule for mutually exclusive events says that P of A or B is equal to the probability of A plus the probability of B. What does that look like in practice? Let's go back to the dice. What is the probability of rolling 2 dice and getting a 5 or a 6? So the probability of getting a 5 or a 6 means that you can break it down into the probability of getting a sum of 5 plus the probability of getting a sum of 6. So the last slide told us that there are 4 out of 36 rolls that give you a sum of 5. There are 5 rolls that give you a sum of 6. 4 plus 5 is 9. So a quarter of the time, you are going to get a sum of 5 or 6 when you roll 2 dice together. Now, note that this rule only works for mutually exclusive events. We'll figure out another rule for things that are not mutually exclusive. One last rule for you here, and that is the general addition rule. So that says if you have A and B, which are 2 events resulting from some chance process, the general addition rule says that if you want the probability of A or B, you can find that by taking the probability of A, adding it to the probability of B, and subtracting the overlap of those two. So the probability of A and B happening. Let's take a look at an example that is not dice related. Facebook versus Instagram. I know you know what those are. So a survey of all residents in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% use both. Suppose we select a resident at random. What's the probability that the person uses Facebook or Instagram? So let's say that we call F Facebook and I Instagram. Now I want the probability of Facebook or Instagram. So that means, using the general addition rule, I find the probability of Facebook, add the probability of Instagram, and subtract the combo. So Facebook was 68%. I'm going to turn that into a decimal. That's 0.68. And then Instagram is 28%, 0.28. Going to add those together and subtract the 25% or 0.25 that use both. And what do I get? 71% chance that the random person that I select uses Facebook or Instagram. And as promised, one last little refresher on Venn diagrams and how we use them. So, to remind you, a Venn diagram consists of one or more circles surrounded by a rectangle. So each of the circles in a Venn diagram represents an event. So if you have 2, you've got A and B, and you've got the intersection in the middle, if they do have an intersection, that is. And then the region inside of the rectangle outside of the event circles is what we call the sample space. Sometimes that is nothing, there's nothing in that sample space, and sometimes there are things in that sample space. So it's very important to include a rectangle when you draw Venn diagrams. So it's really important to understand what a Venn diagram is telling you. So let's go through a few things that can happen in Venn diagrams. First, if you think about an event A, which is represented by this white circle, the outside space, that sample space that's in the rest of the rectangle, is the complement of A. And then in this second situation here, we've got event A and event B, and that intersection, that's what it's called, an intersection, is both A and B, and that's denoted by this little upside down U. That's intersection. And then what makes the right side up U is something that we call a union. So let's say you have events A and B. A union is everything. Everything in A, everything in B, and that also includes everything in A and B, so in the intersection. One last example, I promise. So remember that example of Facebook versus Instagram in that large apartment complex? Remember, 68% use Facebook, 28% Instagram, and 25% both? A Venn diagram would be really useful here if we were to, select a resident at random. So let's make a Venn diagram, and let's find the probability that the person that is selected doesn't use Facebook or Instagram. First thing that I do is I draw my rectangle, and I have my 2 event circles here. F is for Facebook, I is for Instagram. So, it's going to start putting numbers in these things. 25% is where actually I like to start, because that is a just straight up number, 0.25. I like decimals, what can I say? That 0.25 is going to be the intersection of both Facebook and Instagram, because 25% of the residents in that apartment complex use both. And so that doesn't mean that 68% use Facebook alone. 68% represents Facebook use. So that could be Facebook only, that could be Facebook and Instagram. So 68 minus that 25 intersection gives me 43. So Facebook alone is 43% of the residents, and I do the same thing with Instagram. 28% represents Instagram, but remember 25% of that 28% make up all Instagram. So 28 minus 25, 0.03. 3% only use Instagram. And now we have to figure out what goes in the rest of that sample space, which, spoiler alert, gives us the answer to part B. So if I add up 43, 25, and 3, that doesn't equal 100%. So it's the complement of Facebook and Instagram. That's going to be 29% of the residents don't use Facebook or Instagram, and definitely not both. So that is the probability of no Facebook and no Instagram is 0.29. And that's going to do it for this video. Thanks for watching.